One thing I wanted to check before I start mucking around with these selenium rectifiers was to measure the main B plus supply to the set. That's the output of the selenium rectifier voltage doublers and this pi filter, and it's supposed to be 255. So I got my meter hooked in to that exact point. I'm only getting about 213.5 volts, which is well under 255. So I bet these seleniums have worn out a bit with age. Because as these get older, the resistance between the plates gets higher until they finally burn out. So now I'm even more curious to see what kind of effect this will have when I replace these with modern silicon diodes and get that voltage back up to where it should be. I just installed one of the diodes. I simply removed the wire going to the positive lug on the selenium and hooked it up to one end of a silicon diode and attached the other end to the chassis. That's this diode here, so one end goes to ground. You want to make sure you get these in the right way. The bar on here, the cathode, that goes to the positive symbol on the old schematic, like in here. And that's marked as positive on the seleniums here. It's the plus sign there on this plate. And now I'm going to slide a piece of heat shrink tubing over that to insulate the whole thing. And then move on to the other one. Alright, I've got the second diode installed. It's inside of this piece of purple heat shrink tubing down here. And that just leaves me to experiment with this. I pulled out a 120 ohm power resistor, just happened to have a nice one that'll fit in there well, so I'm going to start out with that while monitoring this voltage and see what we get. Okay, I've got my power resistor hooked in, I've got my meter hooked up, so let's give this a try. Remember, 255 is the magic number. Well, it starts out a lot higher. That's to be expected because the tubes have to warm up and start conducting, which will load down that resistor and it'll start dropping. And I can already tell that I've got too much resistance in there. It's dropping down even lower than it was with the seleniums in place. And there's a picture, but it's much, much dimmer because there's just not enough juice in this set. Alright, so I was off by quite a bit, so I think I can change this pretty drastically. Maybe go down to more like 50 ohms or thereabouts. Alright, I've gone through a couple of iterations and I'm all the way down to 32 ohms now. I've got that installed, so let's give it another try. Shoots up a bit higher this time. It should start dropping. Still too much resistance, huh? So maybe around 25 ohms or so. I did a bit more futzing, now got it up to 262, which is a little bit too high. So I think a little more tinkering, fine tuning, and I'll get this just the right value. Then I'm going to install a terminal strip and mount all these components nicely and neatly so it's safe. And then I'm going to start troubleshooting to see if I can improve that horizontal sync. I'm going to make one more modification to the set for safety's sake, and that's in the power switch. The way it was originally configured is one side of the AC cord went to a switch that was connected right to the chassis, so they would open and close the connection essentially to ground, and the other side was always live. What I want to do is make this connection always on and put the switch up here, and then I want to use a polarized plug on this set and ensure that this is always neutral, which means even if this was plugged in, you could get your hand in here and touch this exposed metal you would not get a shock. The original power prongs on here are non-polarized, meaning they're both the same. And this is the type of original plug that was on here. Go on like that. That's actually attached to the back of the set. This one's all rotted away, so I'll be taking this off. And apparently there's a trick where you can take a new cord and put it into boiling water, and it will soften up this plastic material enough that you can slide it over the old rivets. And when it cools, it'll shrink and then stick on there good. So I figure that if I get a polarized one of these and put it on here, that even though these two may be the same size and these two are the same size, it's part of the case, so nobody can, you know, get this off and flip it around the other way. Otherwise, I would have to remove this and try to find one that's polarized, and I don't think I've got anything like that on hand. At any rate, it's fairly easy to do. Here's the volume control, and here's the switch on the back. I've already inserted the two leads. One was going right over to the copper chassis, and the other wire just goes right down here to that power input circuitry. So I simply remove the power connection. I'll resolder this one back on, and then run a second wire down from the switch to the to where my fuse is. So the switch will be between the AC input pin here, which goes through this wire over to the switch, and the switch goes back down to the fuse I'll be installing. Alright, I think I'm finally in the home stretch. I mounted a terminal strip down in here and mounted all my components. Got the thermistor, CL90 back in there. Here's my diode. There's a fuse inside some heat shrink tubing. And I ended up using two power resistors in parallel to get a value of about 22 ohms. It turned out to be just about perfect. And I finished rewiring the power outlet so that this bottom one should be neutral, goes right to the chassis, and the other one goes to the switch. So flip it over, hook up power, and see how it works. I've had this set running for a while, and it seems fine with all the power supply modifications I made. So that just leaves this problem with the horizontal sink being so flaky. So what I'm doing now is checking some test points with a scope and referring to the schematic here. I pulled out an older scope, a classic Tektronix 465. It's a scope I used for years before I got this fancy one. Just for nostalgia's sake, and I thought you guys might like to see something a little bit different. On this scope, I'm always just pushing this auto scale button, which automatically sets the horizontal and vertical settings. It gives you a nice reading. This one you actually have to turn the knobs. But otherwise it works fine. So I'm starting out down here in the horizontal circuitry, and I'm checking this point right here, which is supposed to be a sawtooth with a peak-to-peak voltage at 20 volts. And that is right down in there. And there we go. I got about 10 volts per division, so that's 20 volts peak-to-peak. That's fine. Now this other test point here is supposed to look like that, and what I've got looks a bit different. Brighten this up a bit. So what I'm going to start doing is checking some of the circuitry around that area, and that's not good. And see if I can get it to, see if I can track down the problem. So I'm getting that. But with that little squiggle I got on the left edge does look like that signal. So I think this signal might actually be comprised of several components. So yeah, that pretty much looks like that. Also 20 volts peak to peak. So I'm not sure. I'm going to keep working my way through. There's also this, which is a resistance measurement chart. They don't give you a voltage measurement chart, which I find odd. Normally these service docks have a grid like this where they show you what the voltage should be on every pin of every tube. They don't have it for this, so they give you the resistance, which is normally you hook up an ohm meter to the ground or the chassis and then to these points, and you should get these various readings. So between this chart and these waveforms here, I'm hoping I can isolate the problem. My gut tells me it's this. What this is a dual selenium rectifier, just like, well, I shouldn't say just like, it's made of the same material as the big power rectifiers, but it's meant for low, much lower signal levels. And they tend to last a lot longer because there's just so little power going through them, and it's all encapsulated in plastic. See if I can show you, kind of buried in this set. It's a little green thing down in there. So not so easy to get at. There's some debate online about what they should be replaced with. Some guys say you need to get another new old stock selenium rectifier to put in there. Some say you can use just a plain old 1N4007 power rectifier. Some say it should be a small signal rectifier. Some say it should be a Schottky diode. Well, I'm going to start with the simplest thing that I have plenty of on hand, which is a 1N4007, and just hook two of them up end to end, just like the schematic shows here, and see what difference it makes. I pulled that selenium dual diode rectifier and put in 1N4007 rectifiers. And now, according to the owner's manual, what you do to get the horizontal lock working properly is you rotate the control clockwise till you lose sync like I've got here, and then go counterclockwise till it locks in and centers the picture. Like so. Now before, when I had a picture like this, whenever I would touch a control, the picture would flip out and I would lose sync, but it seems to be a lot more stable now, which is awesome. But also trouble if I flipped the channel and then went back, it would lose sync. Alright. And the final trouble I was having is whenever I would get everything set perfectly, turn the set off, and then back on, I would have to go through all that again to get a stable picture. So I just turn it off and back on. Hopefully the picture will lock in stable. Alright. So I think this restoration is just about done. Here's a little bugger that I pulled out. And here's what it looks like in the schematic. So I did hook this up to both a digital multimeter and a VTVM, and it measured infinity no matter what range I tried or polarity of the meter leads. I have heard these are tough to test though, because I think you need to put higher voltage than a meter normally puts out to hit the breakdown voltage of the diode. But hey, either way, it's gone now and the set's working better, so that's all I care about. So about all that's left now is cosmetic stuff. I'd let these knobs soak for a while and they're looking a lot better now. I think I'll fill in these recesses with maybe some of that gold lacquer stick like I did on my GE radio recently. And then there's the cabinet. Here's the cabinet. I've been trying to clean it as best I can. The problem is in these louvers here, a lot of dust and dirt has settled over the years and kind of baked on because this sec is so warm during operation. I've been spraying it with this stuff, and if you let it sit for a while, and then I've been using Q-tips to clean it out, it gets better. So I've done this side, I haven't done this yet. It's not great, but I'll do another pass. Eventually I will get this repainted, but that probably won't be for a while. So I just want to clean it up, make it look as nice as I can for the time being.